Hi everyone. Okay, we are in Unit 8 now, where we're going to talk about similarity. And for the first section, 6.1, we're talking about ratios, proportions, and what the geometric mean is. Ratios, right here, we'll start here. Ratios compare two different things, two values. And we write ratios in one of the following ways. There's the A to B, A colon B, or with the word to, A to B, when we're comparing two things, A to B. And for us, we're going to mostly probably be using this A over B in fraction form for when we solve, when we're solving proportions. But first let's talk about equivalent ratios. And if you have an equivalent ratio, it means that the two ratios are the same when they're simplified. So if I'm going to simplify this ratio, I'm just going to simplify the number 64 over 6. The m's will cancel. And then 64 over 6 will reduce to, so we're just reducing the fractions, 32 to 3. So those would be equivalent ratios, have the same simplified form. Let's take a look also at a ratio that aren't in the same unit of measure. So for example, let's do another one here. If I had an example of 5 feet to 20 inches. Okay, 5 feet to 20 inches. And we want to reduce this ratio. We want to find the equivalent ratio. What would our ratio be? Let's look at if I had, let's take a look at how many inches there are in 1 foot. And this is going to give us the ratio. I have 12 inches, and I want to write that on the top so that the inches here on the bottom, I'll show you in red, the inches here and the inches here will cancel. And in 12 inches are 1 foot. In 1 foot I have 12 inches. So then the other thing we get here is that the feet cancel. And then I'm going to get 5 times 12, 60, over 20. And that's going to reduce to 3 over 1. So that ratio is 3 to 1. That's the ratio, 3 to 1. Now, in the next example, we're going to also look at how to use ratios to find measures or dimensions. The perimeter of a rectangle is 484 feet, and the ratio of the length to the width is 9 to 2. That's the ratio. Now, what that means is that when I put the length over the width in fraction form, it would reduce to 9 over 2. Okay, that's going to reduce to 9 over 2. So if you look at when we simplified, back up here, when we simplified 64 over 6, we took out the same factor on the top and on the bottom. So we divided the top and the bottom by the same number. And that's basically what we're going to be looking at here, although in this example we don't know what that factor is we're going to take out. And so how am I going to find that? Okay, I always like to look at first at a picture. I like pictures. So if this were my rectangle, I know that the length is usually the longer one, and it's going to be 9x, some factor that we're going to take out, and then the width is going to reduce to 2 times some factor that we're going to take out. So my length is 9 times that factor, and my width is 2 times that factor. And then it would reduce to, if I put the length over the width, it's going to reduce to 9 over 2. And that's what we're looking for. And so first of all, I have to figure out if the perimeter is 484, what is my x value that I'm factoring out? So let's take a look at that perimeter. I'm going to pick a different color now. Perimeter is 2 times the length, so that's going to be 2 times 9x plus 2 times 2x, which is the width. Perimeter is that formula, 2 times the length plus 2 times the width. My perimeter then is 18x plus 4x. And then I'm going to go ahead and say over here, and we'll just take that off, my perimeter they gave me is 484 feet. So I know what my perimeter is. Now I can add all this up, 22x equals 484, and my x value is 22. So that's my x value. Now, what we're looking for here, though, is the area. That's what I have to find. And we know area is length times width. So we're going to find area, which is the length. And if I do 22 times 9, because I'm going to take 22, what the x is, and I'm going to plug it in here for the length times the width. So I'm going to get 9 times 22, which is 198, times 22 times 2, which is going to give me 44. And so the area of this rectangle is 8,712 feet squared. And that would be the area. Okay? Okay, let's try another one of those, but with a triangle this time. Now, triangles have 3 angles, so we're going to be looking at an extended ratio. So that means more than just 2 that I'm comparing to. I'm comparing 3, all 3 angles. And the extended ratio is going to be 1 to 2 to 3. That's the extended ratio. So we're going to find the measures of the angles. So here's what we do. We're going to take our triangle and look at the angles. We have 1 to 2 to 3. Now that's what it would reduce to. If I made it like maybe a triple fraction. If I reduced all of them, it's going to reduce to 1 to 2 to 3. Well, I don't know what that factor is that we're going to be taking out. So we're going to put that factor in as x's. So we're going to get 1x, 2x, and 3x are the measures of those angles. All right, and so we know that the 3 angles in a triangle add up to 180. So I'm going to get 1x plus 2x plus 3x equals 180 degrees. So when we add all of those together, I'm going to get 6x equals 180. All right, and so that's going to make x equal to 30. Now, if I want to know what the measures of all the angles are, the measures are 1x, which is 30, 2 times 30, which is 60, and then 3 times 30, which is 90. And so those are the degrees of all 3 angles. Okay, so let's look at proportions. Proportions are an equation that show 2 ratios being equal. So we set 2 ratios equal to each other. And this is usually what they look like. 2 fractions on each side. So we have A over B equals C over D. The means, if you've ever heard of this, the means and the extremes, the means are B and C, and the extremes are this side, A and D. Those are the extremes. And so we all know, or we probably have used, I'm sure y'all have used, that we cross multiply. If we don't know one of those values, we would cross multiply to figure it out. That's how we solve proportions. And really what we're doing is taking the product of the means and then setting that equal to the product of the extremes. We're cross multiplying. Okay, let's solve a couple. So if we're going to cross multiply, we would take x times 5, so that's going to give me 5x, equal to 2 times 8, which is 16. And so when I solve, I'm going to divide both sides by 5, and x would be 16 over 5. And so that would be your answer. All right. Now, what we have to pay attention to on this one, on this particular problem for the second example here, is when I have a number, a value that is being, I've got y plus 1 or x plus 6 or minus 4 or something like that. When I have more than just one term under there, you need to be careful to put that in parentheses. You're going to need to put it in parentheses in order to multiply. Okay, so let's do 2 times y plus 1, and it needs to be in parentheses because I have to multiply both of those terms by the 2. And that's going to equal 1 times 32, which is 32. So when we distribute the 2, we're going to get 2y plus, and 2 times 1 is 2, and that's where you have to be very careful not to forget you've got to distribute that number. equals 32. So let's subtract the 2 from both sides, 2y. When I subtract the 2 from the other side, I'm going to get equals 30. And then I ran out of room, so y equals 15. Okay, let's look at one last idea here from this first section, is the geometric mean. Now, you remember from previous classes where we talk about the arithmetic mean, which is when we take however many numbers we're adding together and we want to find the mean, we add them and then divide by the number. And so if you're finding the geometric or the arithmetic mean of two numbers, you'd add the two numbers together and divide by 2. Well, the geometric mean satisfies, it's two positive numbers that's going to satisfy this following equation. A, which is the first number, over an x equals x over b, which is the second number. And so what we get in this formula is x squared equals a times b when we cross multiply. And more specifically, this is what we want to always remember, the geometric mean is when I multiply the two numbers and then take its square root. So that's how we differ from the arithmetic mean. Think arithmetic, when you add the two numbers and divide by 2. In the geometric, we're going to multiply the two numbers and then take the square root. So let's find the geometric mean of 4 times 12. So my geometric mean is going to be the square root of 4 times 12. So we're going to, you can multiply this together, or if you have bigger numbers, one of the things I will do is simplify my radical. And this is where we're going to have to simplify radicals. We will, no decimals, simplify your radical. So first of all, I'm going to look at, under this square root, I have a 4, and then I know 12 is 4 times 3. And so my geometric mean, since it's a square root, I need 2 of the same number in order to take 1 out. So there's a pair of 4s. And so my geometric mean is going to be 4 times the square root of 3. Now, if you don't remember, or if you're not sure about your two numbers when you're multiplying, remember that we can also do the factor trees. So if you've got 4 times 12, and I wouldn't, if you're going to do the factor trees, I probably wouldn't go ahead and multiply them together and then do the factor trees. I would just go ahead and do the factor tree from here if you need to. So 4 we know breaks down into 2 times 2, and now let's break down our 12. We've got 2 times 6, and then 6 breaks down into 2 times 3. So now I've got all of my prime numbers, and remember that we're looking for groups of 2. So this number, any number needs the same number as a partner in order to come out from under the radical. So here's a group of 2. So I know I can take out 1, 2. And here's another group of 2. So I know I can take out another 2. But remember, when you take a number out, these are all factors, so they have to be multiplied back together. And then what we have left under the radical is a 3. And then 2 times 2, that gives me the 4 times the square root of 3. And that is it for our first section.